What I want to do is I want to go and move on from that skill number 4 and take what we were able to calculate relative to belt deflection and actually do that in the hands-on activity and skill capability built into skill number 5 on the 970 ME1 system. So I've taken the liberty to do a little bit of pre-setup to where I've mounted the adjustable motor base, the electric motor, a set of pillow block bearings, the shaft through there, driver pulley on the motor and driven pulley on the auxiliary shaft. I've also plugged it into electricity, going to put my safety glasses on for safety, and I've got it locked out and tagged out right now. So what we really want to demonstrate is the ability to understand how to effectively put on a V-belt onto a motor drive system. So I've got this installed, and obviously I think the age-old way of being able to determine if a belt is too tight or too loose was to put some type of pressure on it, which I see a lot of technicians doing. Some of them will hit it, some of them will push, and the age-old question is how loose is too loose? Obviously what I've got going on here is too loose. What most people don't understand is that there is an actual scientific method of being able to determine how tight we make this belt. So in the last exercise we looked at belt deflection based on diameter of the driver of the smallest pulley in our ratio, and also the length between motor shafts of about approximately 14 inches. So I've got a 3-inch pulley on the motor. So if I run through all of the calculations, I come up with about 1/4 of an inch of belt deflection per inch of my belt. So I can transfer all of that directly to my belt tensioning device. So on the bottom, I can put in my 1/4 inch, and based on the chart that we looked at in the last exercise, I know that it's approximately 3.4 pounds that I need to be able to move this belt or deflect the belt. So we always say that we want to measure that by putting a straight edge along the belt itself, and then we simply push down. And you can see in this case, I have it obviously way too loose. So let's go ahead and tighten that up just a little bit. We'll come over here and adjust the adjustable base, tighten the belt up. I'm going to measure here just a little bit, see if I'm even in the ballpark. Now I want to go back and be able to use the tool as described. And if I push down there, looks like I need it just a little bit tighter. So let me tighten it up just a little bit more. I think that will probably do it. So as I put my straight edge back on there and put my deflection gauge, I go down my 1/4 of an inch, and up here on the top I'm at my 3.4 pounds. So I know now scientifically, according to this belt, the width of the belt, the length of the belt, and my drive system, that this belt is now tensioned properly. So I'm going to go ahead and stow my straight edge. I'm going to go ahead and tighten up my adjustable motor base, and I'm going to go ahead and I'd like to go ahead and test run this. So we're going to install our safety guards. We've got safety switches embedded in the actual work base itself, so that if anything, if these guards were to rattle off or be moved apart, the system would immediately shut down. So now that I've got the guards in place, I can take off the lockout tagout device. I can power up my system. I've I've got full power, and let's go ahead and start this and see how it runs. So everything seems to be running as it should. The belt's not flying off. Everything looks to be perfectly tensioned for this particular application. In subsequent skills, obviously, we could put a prony brake on this, put the motor and the shaft and the power transmission system under load, and be able to measure the overall amp draw of the motor, making sure that things are good. We can, for learning exercises, deflect the actual shaft, the alignments. We can go too loose, we can go too tight. We can set up a lot of different applications to allow a learner to go through and figure out how do we do this in the most correct fashion. So that's how we take the blended approach from e-learning and understanding how to calculate some of these variables into a language that we can both understand and, more importantly, measure.